Students, I am Chalma Reddy. In previous class, we are completed Leibniz rule related problems, concept and one problem we are done, 69th one. Now 70th question. Limit extends to 0 x power 4 divided by integration 0 to x square tan inverse t dt. That is equal to, substitute the limit numerator and denominator, you will getting 0 by 0 form. The limit value you are getting 0 by 0 form means, so what we have to do, 0 by 0 or infinite by infinite, use that L'Hospital rule. L'Hospital rule means numerator and denominator do one time derivative. Numerator x power 4 derivative 4x cube, but denominator derivative means use Leibniz rule related problem. This is a formula. So use this formula. So that means derivative integration is cancelled. Substitute the upper limit and lower limit. X square is the upper limit, tan inverse of x square into derivative of x square, minus lower limit, tan inverse of 0 into derivative of 0. Now limit x tends to 0, 4x cube divided by derivative of x square, tan inverse of x square, derivative of x square, that is 2x. Here see the cancellation, 2 times, and 1x also cancel, remaining 2x. Finally, limit x tends to 0, numerator x square divided by denominator tan inverse of x square. We know the formula, limit x tends to 0, tan inverse of x by x, or limit x tends to 0, x by tan inverse x. That value should be 1. Yes or no? So here tan inverse x square by tan inverse of x square. That value should be 1. That is standard result. Now this is. So correct answer is first option. Here one more 2 is there. We are not written. So now I am going right. 2. So 2 into 1. Answer is 2. Yes, yes. So this is not first option. Second option is correct. Here we are done calculation mistake. So here apply the limit numerator and denominator, you will get 0 by 0 form. Then go for L'Hospital rule. LH rule means numerator and denominator do one time derivative. Denominator you are done derivative means derivative of x power 4, 4x cube. Numerator, apply Leibniz rule. Just in place of t substitute x, sine cube x, cos x, dx, minus. Lower limit also substitute, you will get 0. After that, 1 by 4 limit x tends 0, sine x by x whole cube limit x tends to 0, cos x, derivative of x means 1. So finally you will get the answer 0.25. First option is correct. So form only. So here also apply that LH rule. LH rule. That means numerator and denominator do that one time differentiation. Numerator you are done derivative means derivative integration cancel. Now substitute the limits tan inverse of x whole square derivative of x minus tan inverse of 0 0 derivative of 0 0 divided by denominator root x square plus do the differentiation. derivative of root 1 by 2 root x square plus 1. And the numerator, what we get? Internal derivative 2x, 2 to cancel. Now limit x tends to infinite, tan inverse of x, tan inverse of x whole square, derivative of x is 1. In denominator, x by, inside the root, take x square common, outside the root will come x. Now here inside the root we get 1 by 1 plus x square. Here x cancel. Now substitute the limit. Tan inverse of infinite whole square divided by 1 by under root 1 plus 1 by infinite means 0. What is tan inverse of infinite? Pi by 2 whole square, and denominator 1 by root 1 1. Total answer is pi square by 4. So which option is correct? Third option is correct. Students, all of you understood now? Students, see the next question. What they are given? The value of limit x tends to 0, integration 0 to x e power x dx whole square divided by integration 0 to x e power 2x square dx. 2x square dx. If you are substituted limit, numerator you will get integration 0 to 0. 0 to 0 means there is no value. Denominator also, you will get 0 by 0. So use Hell Hospital rule. How to do that? If you are doing numerator one-time derivative, what happened? Tell me. Whole square is there. If derivative of x square means, how we are writing? That is 2x. Then internal derivative x, derivative of x should be 1. Overall we get 2x. Here also same like that. First do the derivative. What happened? 2 into integration 0 to x e power x dx into, now do that internal derivative. Internal derivative means use Leibniz rule. E power x derivative of x1 minus, sorry, only I'm substituted here upper limit. Now substitute lower limit. E power 0 derivative of 0, that should be 0 now, divided by. In denominator also apply the Leibniz rule. E power 2x square derivative of x, that should be 1, minus, substitute upper limit, sorry, lower limit, e power 0 derivative of 0. So finally numerator and denominator we are applied Leibniz rule. Now observe the numerator. What happened? See, 2 into integration 0 to x e power x dx into e power x divided by denominator e power 2x square, e power 2x square. Next students, numerator e power x send to denominator, limit x tends to 0, 2 into integration 0 to x e power x dx, and denominator e power x is coming denominator means you will get e power 2x square minus x. Now again apply that limit. You will get 0 by 0 form, I think. 0 by 0 form. So then what we have to do? Apply the Leibniz rule. Apply the Leibniz rule. Or denominator cannot be possible 0, no? Denominator we get 1. So do one thing. Numerator apply that integration. 2 into, what is integration? E power x dx. E power x. Substitute that lower limit and upper limit. This is the limit. Denominator is e power 2x square minus 6. Students, are you understood? I didn't apply that L'Hospital rule. Numerator directly applied integration. Now, numerator, limit x tends to 0. Numerator we get 2 into e power x minus e power 0 is 1. Divided by e power 2x square minus x. Now substitute the limit. What happened? See. Substitute the limit. Then what happened? 2 into e power 1 minus 1 divided by denominator e power 0 minus 0. That is 1. 1 second. So numerator here, this is e power 0. E power 0 value is 1. 1 minus 1. Denominator e power 0, that is 1. Numerator 0 will come. Denominator 1. 0 by 1, 0. This is the answer. Students, see the options. Fourth option is correct. Fourth option is correct.